Welcome back. This is the second lesson recording for IM1, January 8th, 2021. Now we're up to card number 5, where we are matching the terms. You should have 4 decks, each with 3 cards. Okay, so now you have different terminologies. Remember, A of 4 or T of some number refers to the value of um, the term on the sequence, and 4 little 4 here tells me that it's the fourth term. So this tells me is the fourth term is 2, which is the one that says sequence whose first term whose fourth term is 2. Okay, well, I don't see it, so let me just keep finding a sequence whose second term is 9. A sequence whose second term is 9. I see the second term is 9 here, so I'm going to match with that. Let's bring you over here. Um, okay, and then a sequence whose sixth term is 16. Sixth term, 1, 2, 3, 4, 5. There are no sixth terms here, but I do see a sixth term on this one to be 16. So I'm going to match that with this. And I have a few more cards here. A sequence whose first term is number 2. First term is this one with number 2, which is here. A sequence whose third term is 5. Third term is 5 is this one. Okay. All right. Then let's look at the notation. This tells me the A of 4, that's the fourth term, is 2. Fourth term is 2. Fourth term is 5 here. Fourth term is 16 here. Fourth term is 2. This one is 2. So I'm going to match with this. A of 2, that means second term of the sequence is 3. Second term is 3. Second term is 3, this one. Okay, so I am going to move you there as well. All right, oops. Okay, and then A of 4, that means the fourth term is 5. Fourth term is 5, that's this. And then finally, this must match with A of 3, that means third term is 9. Okay, so they're all matched. Now I'm done. If I go to the next slide, it will tell me, great work, you got them all right. Okay, so that was the notation. Now let's talk about classification of classifying sequences. Sequence can be classified as arithmetic if the rule is that you are adding a constant, that means the same number, to the previous term. While it's geometric if you are multiplying a constant, that means the same number, to the previous term. And then finally, neither if you have some other rule. Okay, it's not arithmetic or it's not geometric. So it's neither arithmetic, it's neither geometric. So it's not adding some constant number and it's not multiplying some constant number. So sequence can be classified as arithmetic, geometric, or neither. All right, so then I want you to tell me in private chat, okay? So now with the first sequence that we've been dealing with, 1, 3, 5, 7, 9, 11, is this arithmetic, geometric, or neither? Okay, arithmetic is when you're adding a same number to the previous number to get the next number. So here I am actually adding 2. Okay, I am adding 2. That means this is going to be arithmetic. The second sequence, I am multiplying the previous number by 2. So I'm multiplying some number. So that means that's geometric. C is I am subtracting. Oh, that's not same as adding, but that is actually adding a negative number. So subtracting some number is same as adding is negative. So you are adding, so this is arithmetic. While as the fourth one, is you are not adding any particular constant number, nor are you multiplying by some constant number. So this is going to be neither. Okay, so now let's talk about common difference. So if you have a arithmetic sequence, okay, not for geometric, just arithmetic sequence, that means you are adding some particular number each time to the previous number to get the next number, right? Then you're going to have a common difference, and we use the letter D, which is the constant or the same number that is added to the previous term. So just in the arithmetic sequence, you have what we call common difference. And for example, if you have 3, 13, 23, 33, 43, what are you adding to the previous number to get to the next number? You're just adding 10, right? So you're adding 10 to each of the terms, so the common difference is 10. What if you have 5, 3, 1, negative 1? What are you adding? Well, you are adding a negative 2, or you're subtracting 2, but or you can think of it as negative 2 is being added to each of the previous term to get to the next term. So the common difference in this case is negative 2. What about this example? Negative 2.5, negative 3.0, negative 3.5, negative 4.0. What do you think? What number are you adding? Okay, I'm subtracting 0.5 here, and another 0.5, and another 0.5. So you're actually subtracting 0.5 or adding negative 0.5. So in this case, the common difference is negative 0.5. All right, so what about common ratio? Just like in arithmetic sequence, you have common difference. In geometric sequence, that's where you are multiplying by a same number. You are going to have common ratio. You do not have common difference because the difference is not the same, but you are multiplying by some particular number r, which is the constant or the same number that is multiplied to the previous term. So for example, if you have 3, 6, 12, 24, what am I multiplying to the previous number to get to the second number? I'm multiplying by 2, and then another 2, and multiplying by another 2. So the common ratio in this case, since I'm multiplying by 2, is 2. What about this sequence? Okay, 2 becomes negative 3, negative 6, and negative 6 becomes 18, and 18 becomes negative 54. Oh, it's flip-flopping between a positive and negative number. Can you think of some number I need to multiply to 2 to get to negative 6? That's right, I am going to multiply a negative 3. And if I multiply negative 3 to negative 6, negative times negative is positive, so I am actually going to get positive 18, and then multiply negative 3, negative 54. So in this case, I am multiplying negative 3. So my common ratio is negative 3. What about this? Okay, 8, 4, 2, 1 half. Okay, what number am I multiplying to get to the next number? I'm actually multiplying by half. Okay, multiplying by a half is same as dividing by 2. So it's 8 divided by 2, or 8 multiplied by half. 4 multiplied by half is 2, 2 multiplied by half is 1, and so on. So in this case, the common ratio is half. Okay, so now you're going to go on to decimals, card number 6 to 14. Please pause the video and see if you can work through them yourself on your own. And I'm going to go through them together. Okay, so now it's asking you to write the first 4 terms. That means I need to come up with 1, 2, 3, 4. So I'm coming up with 4 terms, and it will continue. With a of 1 is negative 2. That means the very first term, remember the little number tells me the term number. So the very first term is negative 2. So I'm going to put negative 2 right here. That's my first number. And with the common difference of d is equal to 3. What does that mean? that means it's a arithmetic sequence. That means you are adding 3 to previous term to get to the next term. Negative 2 plus 3 is going to be positive 1. Positive 1 plus 3 is going to be positive 4. Positive 4 plus 3 is going to be 7. Okay? And next card just tells you the answer so that you can check whether you did it correctly or not. And I got it correct. All right, so then next one, write the first 4 terms of arithmetic sequence with a of 1 is equal to 5. That means the first term is 5, okay? And the common difference this time is negative 2.5. If you're adding a negative number, that means you're going down. The number's getting smaller, and you're subtracting 2.5 from 5. 5 minus 2.5 is 2.5. And then 2.5 minus 2.5 is going to be 0. And from 0, if I take another 2.5 is going to be negative 2.5. And the list continues, so I am putting dot, dot, dot to say that this is only the first 4 term, but the list will continue. And that's my answer. And here is my answer, and this is the correct answer, and it looks like I got it correct, so I am good. All right, then what about this? Write the first 4 terms of the geometric sequence with a of 1 is 3. It's a geometric sequence with the first term is 3, and then but your common ratio is 4. That means from to the previous number, you are multiplying the common ratio, which is 4. So 3 times 4 is 12. And 12 times 4 is 48. And now 48 times 4, that gets a little bit tricky, okay, is actually 192. That's the first term. But the list continues, so I am going to put dot, dot, dot there to denote that it's going to continue. Okay, then move on to the next card. And that was my answer, and that is identical to the correct answer. So yeah, I'm doing well. Okay, and then last one. Write the first 4 terms of geometric sequence where a of 1 is 3. That means the first term is 3. But the common ratio is 1/2. That means you are multiplying half to 3 or dividing it by 2. So 3 divided by 2 is what? 1.5, or 3 divided by 2 or 1.5, up to you. And then 3 over 2 multiplied by half. Okay, so I'm dealing with fractions just because it's easier. Okay, so I am again multiplying. Right now I have 3 over 2, multiplying that by half. Remember, how do we multiply fractions? We multiply top with top and bottom with bottom, and you get 3 times 1 is 3, and 2 times 2 is 4, so it's 3 over 4. So that's going to be 3 over 4, comma, and then to 3 over 4, I need to multiply another half, don't I? And again, 3 times 1 is 3, 4 times 2 is 8. So it's going to be 3 over 8. And the list continues. Okay, and I'm going to submit that. Get rid of my work. Okay, and that was my work, and that's the correct work, so I am good. And we will continue with the next lesson recording.